Good evening, sir.
Good evening, everyone.
Good evening, sir.
So today we will continue our discussion
Good evening,
on.
sir.
Good evening. Good evening. So within 2 minutes we will be starting. Let everyone join. I think everyone is joining. So till then, all of you can start your cameras. Everything. We'll start the class within a few minutes. In a minute we'll be starting. Can you people see the screen? Is the screen visible to everyone?
Yes, sir.
Okay, so these are the topics that we are supposed to cover in this, and we have also done a few of them. We had done introduction to force in the last class. Contact forces, non-contact forces we had discussed. We had discussed about balanced and unbalanced forces also. So up to here we had discussed. We will also discuss today we'll be discussing Newton's laws of motion. So before we continue with the Newton's laws of motion, we will add here before we start with the Newton's laws of motion, can anyone tell me, just having a quick revision? So, Charantej, what is a force?
Sir, force is a push or pull, sir. A push or
Okay,
pull is known as a force.
a push or pull is known as a force. Very good. What are contact forces? Mohammad Owais. Owais, what are contact forces? Varshit,
Yes, sir.
Varshit, what are contact forces?
So contact forces are the forces which need contact to work on.
Which need a contact for their action. For example,
For example, they're
yes,
pushing a heavy. They're pushing a heavy box.
Yeah, pushing a ferry with your hand, that is a contact force. Very good. Any other examples of contact forces? Ronit? Ronit, your camera is not on. And Lasya, your camera is also off. Gagan Samudra, your camera off. Keep your cameras on.
Sir, in my desktop, the camera is not working, so I connected to other phone.
Okay, okay. No issues. Continue now then. So Ronit, can you tell what are
Opening the video with my other device, sir.
okay. So can you tell what are contact forces? Ronit, what are contact forces? Ronit, you are muted. Can you unmute and tell what are contact forces?
Sir, contact forces are the forces which need contact to.
Forces that act when there is a physical contact between the two bodies. So such forces are called as contact forces. Can you give any two examples for contact forces?
Sir, pushing a car.
Pushing a car, that is a contact force. Gagan
Uh,
Samudra. Gagan Samudra.
Sir, Gagana.
Gagana. Okay. Gagana. So what about the contact or non-contact forces and contact forces?
So, contact forces is physical contact for a force to move an object, and non-contact forces do not need any physical contact.
Okay. The forces, basically the forces which can act without a physical contact, they are non-contact forces, and the forces which can act with which need a physical contact for their action, they are called as contact forces. So here some of the definitions are given for the contact and non-contact forces. Okay. In the case of non-contact forces, we had seen that magnetic forces are non-contact forces, electrostatic forces are non-contact forces. Right. So we have seen electrostatic forces, non-contact forces, gravitational forces as the non-contact forces. Right. So all these, they are non-contact forces, whereas muscular force, frictional force, they are contact forces. They cannot act without a physical contact. So non-contact forces, they are gravity, magnetic force, and electrical force. These forces, they are non-contact forces. And now we will be doing balanced forces. So we had done in the last class about the balanced forces also. And Lasya, can you tell about the balanced forces? What are balanced forces?
So, balanced.
Hmm?
So, balanced forces are in what?
Yeah. Balanced forces are
So, balanced force means in which the force is the object can balance a force is called a balanced force.
in which the object can balance. Hmm? If you add up all the forces and their sum becomes 0, if by adding all the forces we get their total sum as 0, so such forces are called as balanced forces. We will see an example of balanced force over here. Yesterday we had done about force, right? Okay. So this is what we had done yesterday. Let's start with this. So today we will be deciding how to find out the forces are balanced or unbalanced. Okay. If you have a number of forces acting and their sum becomes zero, see how the sum will become zero, balanced and unbalanced. Now, suppose you have any object and there are a number of forces, two or more forces acting on it. So we follow a general rule, and that general rule says that on a number line, I think all of you know about a number line.
Yes.
On the number line, towards the right side, of the number line, we take all the numbers to be positive, and towards the left side, we take the numbers to be negative. Right? In the similar way, we can follow another convention that all the measurements which will be made above the line, they can be taken as positive, and the measurements which will be made below the line can be taken as negative. Okay, so you just have to tell whether in the given cases the forces are balanced or not. Okay, so here you have an object, and let's see whether the forces are balanced or not. So here you have two forces acting on a small object. They are like this. Here you have 3 Newton of force, and here you have 5 Newton of force. So are the two forces balanced?
No, sir.
Yes, are the two forces balanced? For this
No,
one.
sir.
For this one. So here you have,
Yes, sir.
okay. Here you have 5 Newton force and 5 Newton force. Okay.
Yes, sir.
Now here I give you one more. You just have to tell whether the forces are balanced or not. Here you have 7 Newton force. Here you have 3 Newton force.
Yes, sir. No, sir. No, sir.
No, sir.
Because it will move towards the left, sir. Because it has more Newton force than right side.
So here you have 3 Newton, 3 Newton.
Yes, sir.
Balance.
So, okay. So for the first one, is the first one balanced?
No, sir.
No, sir.
No, this is not balanced. So we'll say that this is unbalanced force. Then what about this one?
Yes,
It is
Second one,
balanced, sir.
Balance.
is it balanced?
No, sir.
Yes,
Yes,
sir.
sir.
Okay, are the two forces acting in the same direction, or are they acting in opposite directions?
In the same direction.
They are acting in same direction. It is like one person is pushing the car and another person is pulling the car, but both in the same direction. So will the forces
Let us
cancel each other or will they add each other?
add each other.
Yes, here the forces will add up each other, and hence we will say here also the forces are unbalanced. They are not balanced. Everyone has understood that in this case the forces are unbalanced. Even if the forces are equal, their directions are same. Okay. What about this third one? Is it
Sir.
balanced or unbalanced?
Unbalanced force.
It's unbalanced. Here we have a net force What is the net force acting here? We have a net force acting which is 4 Newton. We have 4 Newton of net force acting here in the left direction. Okay. 4 Newton left is acting. So it is unbalanced. What about the last one? Is it balanced or unbalanced?
It is
Balance.
balanced.
Balance.
Yeah, it is balanced. Now I will give you one more. So here you have, these are the two forces which are acting. You have 50 Newton up and 15 Newton down. So what about the two forces?
Sir, balanced.
Yeah, they are balanced. Okay, another one. Just another one. Just to add, let's see if you can answer it. So here you have 50 Newton, 50 Newton. Here you have 30 Newton, and here you have 20 Newton. So are the forces balanced or unbalanced?
Unbalanced.
Unbalanced.
Unbalanced. In which direction is the net force acting?
All
Sir.
the four sides.
On the upward side?
Yes, sir. 10.
So it is
Yeah.
balanced at the sides and not unbalanced at the up and down both.
Yeah. So all the forces here, they are unbalanced. We'll say that these forces, they are unbalanced since there is a net force. The sum of all the forces is not 0. Okay. Shall I give you one more?
Yes, sir.
Yes.
Yes.
So do practice this one again. So these are the forces acting. You have 10 Newton upward, 10 Newton upward. Here you have 20 Newton, 20 Newton. So what about the forces? Are they balanced or unbalanced?
Unbalanced.
Unbalanced.
Sir,
What is unbalanced? And what is the net force?
10.
10 or 20? See, both the forces, they are acting in the same direction. So the net force should be 20 Newton.
Yes.
Okay. Yes. So now today we will see about the magnetic force and electric forces that are non-contact forces. So today's topic we have non-contact forces.
Sir, what about nuclear force?
Okay, you want to know about the nuclear forces? The nuclear forces, they are beyond your scope. Okay. So that's why they are even not mentioned in your books.
Okay, sir.
Okay. So you can't say about them. They are beyond your imagination.
It has
Right now.
about nuclear force. It's not mentioned.
Yeah.
In our syllabus, the nuclear force is not so important, sir.
Yeah. In your syllabus, there is no nuclear force. I had given you the nuclear force just for your knowledge that you know that yes, there is some nuclear force also. It is
Okay.
because of the nuclear forces that we are running up those nuclear power plants.
Okay, sir. Thank you.
Okay. So the non-contact forces, we will be studying today all the non-contact forces. That means these are the forces where we do not need any physical contact. So among them, the very popular are magnetic forces. So all of you had always played with a magnet.
Yes, sir.
Yes,
Okay. So what is so typical about a magnet?
sir, it attracts, sir, when an object gets closer.
Okay. So first of all, a magnet attract all the iron object, right?
Yes, sir.
Magnet attracts all the iron objects and iron-like objects. Iron-like objects, they are aluminum, nickel, and cobalt. So iron attracts them. Alnico. Nickel and iron, nickel, and cobalt, they are attracted by the magnet, whereas copper is not attracted by the magnet. So here I am making a magnet, and you see that every magnet has two poles. There are two poles of every magnet. They are called as north pole and south pole of the magnet. So if you suspend a magnet freely, if you take a magnet, tie it with a thread at any of this at the center point and suspend it freely, make it free to rotate so that it will always point in the north-south direction. A magnet always point in the north-south direction. It is because the magnet has two poles, a north pole and a south pole. So we observe here that the similar poles, they have similar poles repel each other. Similar poles repel each other and opposite poles attract each other. So if you take two magnets, you must have observed if you bring the two magnets close to each other, so sometimes they attract and sometimes they repel. Yes. So if you bring a magnet like this, so that their opposite poles are in front of each other. If you bring another magnet near to this, like this. So here you have a magnet like this. You have a north pole here and south pole. So what should happen between the two magnets? Should they
Repel each
attract each other? Attract
They
each
repel
other?
each other. Sir, they
They
repel
repel
each other.
each other.
So they repel
Yes,
each other.
they will repel each other. This magnet will be pushed away from it. So they will be repelled from each other. Okay. And if the opposite poles come together, if you have in the case of magnet, you have two poles coming close like this. So again, here we observe a magnet. Let's say north pole, south pole. You have south pole and north pole. Now we observe that the two opposite poles are close to each other and hence they will attract each other. This magnet will be attracted towards this and this magnet will be attracted towards this. So hence the two magnets will attract each other. Okay. Now there is a general question. Can a magnet repel an iron piece?
No,
Can
sir.
a
No, sir.
magnet ever repel iron?
No, sir.
Okay. So I here is another one. I have a substance. I just 1 minute, beta. There is some call. 1 minute. Okay. So suppose I got two substances. I got some substances, two stones, and I want to test them that whether they are magnets or pieces of iron. Okay. Now I just have I have a magnet, and if I bring that piece towards the magnet attracts it. So will I say that it is iron or a magnet? How will I know that a given piece is iron or magnet? Yes, Charan Tej, how we will come to
Sir,
know that
sir, can you repeat the question once again?
how we will come to know that the given piece of iron is whatever, suppose I got some piece, okay, I got some piece which looks like a magnet and it also looks like iron. I'm confused whether it's iron or magnet, I don't know. So how will I come to know? I can test it with a magnet. I have a magnet with me so that I can test it. So how will I test? How will I come to know that the given piece is iron or magnet?
Sir, you can use the magnet and you can face the magnet towards the north and south direction. We can know that if the poles repel and the opposite poles attract, we can know that it's a magnet.
Okay, but there is nothing written on it. Okay, there are no poles written on the magnet. It may happen that it's a magnet and it's not written over there. हेलो एक मिनट आ गया Okay, see. So how we will come to know that the given piece is a magnet or an iron? So you answered it correctly that if I bring it near the magnet, if I bring it near the magnet, and if it always attracts, if from all the sides it attracts only, that piece will be a piece of iron. And if from one side it attracts and on the other side it repels, then I will say that it is a magnet. It's not iron. Okay. So from this, so here okay. So I write here in one statement, we can check it as repulsion is the surest test for repulsion is the surest test for it. हाँ पेमेंट खाली कोई दबे के अभी ठीक है हम भेज देते नहीं अभी क्या करें ना फोन पे डाले वहाँ पे चल जाते बोलते हैं हाँ फोन पे चाहे गूगल पे जो हम यूट्यूब करें तुरंत अभी रिक्वेस्ट भेज आ जाए अरे तक आके कैश लेना सो we can write here that repulsion is the surest test. Hello. हेलो अरे क्लास चलता है ओके 2 मिनट रुकिए 2 मिनट रुकिए Thank you for waiting. You waited a lot. Okay, so we studied here that repulsion is the surest test for magnets. Then magnetic forces act from a distance. From a distance, that is, they are, I can say that the magnetic forces, they are non-contact forces. Magnetic forces, they are non-contact forces, right? And okay, all magnets have two poles. This is also important point, that all magnets have two poles. Can you name any device which is based on magnetism?
Sir, compass.
Yes, magnetic compass. Magnetic compass is a device which is based on this magnetism. We also have some electric devices which are based on magnetism. Okay, so this was about the magnetic forces. Now we see about the electric forces, or we also call them as electrostatic forces. So electrostatic or electric forces, these are forces between two charges. Okay, one more important question I'm missing out from magnets. Let's see who can answer from the magnet. Okay. Suppose I break a magnet. Okay, I have this magnet and I break this magnet from middle. So what will happen to the magnet? Will it still remain magnet or not?
Sir,
Yes,
it
sir.
will
Will still remain a magnet.
Sir,
Okay. Okay. How many of you say it will still remain a magnet?
Sir, right.
Okay. Very good. So it will remain a magnet. Very good. Very good. It will remain a magnet. But what will happen to my two poles? since every magnet has two poles, right?
Yes, sir.
So, so if I break this from here, what will happen to the two poles?
Sir, it will cut
I'm
into
going,
two pieces.
yeah, so that means
South pole,
whatever my, yes.
pole only, if it will be breaking means it will be dividing the south pole only into north and south.
So what about the new magnet? Suppose I broke this and I got these two magnets, right? So will my new magnets have again north and south pole?
They will have, sir. Yes, sir.
Yes. Okay. So even if you break a magnet, the two poles of the magnets cannot be separated. You cannot separate the two poles. Even if you break the magnet, the two poles will not be separated.
Sir,
Okay. You cannot separate the north pole and south pole from each other. They will always remain there. Every magnet will have a north pole and a south pole. So even if you break it, the smaller magnets will also have their small north pole and south pole. Right?
sir,
Yes,
if we
Pranav?
break the if we break the magnet, suppose if we break out the south pole, how can the north pole form in that magnet, sir?
Yes.
Again,
Yes. If you break this magnet from here, so a new south pole will be formed here and a north pole will be formed here.
how,
You will
sir?
have your formation of a south pole and north pole. A new north and south pole will be formed.
It will be formed.
How it forms, that you will study in your class 12th, in your grade 12th. You will
Interesting
study that.
interesting concepts are all in inter and this 10th class.
Yes. In 10th class, you will just know what are magnets, how they act. So I hope everyone has understood about the magnets. Now we discussed about the electrostatic forces or electric forces. The forces that act between two charges are called as electric forces or electrostatic forces. Just 1 minute. So, as we know that there are two types of charges. What are the two types of charges?
Positive and negative, sir.
Yeah, two
Sir,
types
I
of
have a doubt.
charges. Yes.
How these positive and negative, how these will be formed, sir?
How they will be formed?
There are two charges, negative charges and positive charges.
Okay. I'm coming. The two types of charges, they are positive charges and negative charges. I got a very important question, that how they will be formed,
Yes, sir.
right? Yes. So see, actually the charges are not formed. They are not formed. They are always there. Okay. They are always there. But since the atoms are neutral, so we are not able to get it. We are not able to understand that yes, there is a charge or not. Only if a transfer of charge take place, then only we get to know that yes, there is some charge on the atom. Okay.
But everything has a starting now, sir. How can it be infinite?
What has a starting?
Like everything has a starting point now, sir. It can't be.
No, you can't say that everything has a starting. You
Yes, sir.
can't say that everything has a starting and everything has an end. No one knows what's starting and what's the end. Okay. So it's not that everything has a starting and everything has an end. This is just a property of matter. Charge is a property of matter.
Okay, sir.
Okay. Okay. So bye everyone. We'll discuss in next class about the electrostatic charges. Okay, bye.
Bye, sir.
Sir,
Yes.
Yes, sir.
What pushes the electrons, sir?
What pushes the electrons? Electrostatic forces.
From which the electrostatic forces are formed? Like
Therefore, that the electrostatic forces of attraction between the atom, between the nucleus and the electrons. The nucleus is positively charged.
but you said force is a push or pull, no, sir. What pushes the electrons to revolve around the orbit?
That is the pull of the nucleus. The protons, they pull the electrons to revolve around the nucleus.
Yes, sir.
Okay.